Dr. Cheng. He is the Associate Head and Professor of Civil and Environmental Engineering Department and Associate Director of Great Smart City Institute in the HKUST. He obtained his PhD degree in the Stanford University. He has also taken many leading and advisory positions in different professional bodies in the building and construction industry, like CIC. Today, his presentation topic is Auction of Hong Kong in Reducing Embodied Carbon. May I welcome Professor.
Okay, thank you. Thank you, Mr. Lang. Thank you, Felix. So let me share screen. Maybe I need to. Okay, can you see my screen? Okay, yeah.
Yes.
Okay, so thank you very much, and thanks again for. Okay, so thank you very much for the invitation. Thanks, Green Council, and thanks for the introduction. I'm Cheng, and I'm from Hong Kong University of Science and Technology. Today, I'm very happy to share with you the topic of reducing embodied carbon options for Hong Kong. And for the information, in the following 20 minutes, I will share with you different options to reduce the embodied carbon. There will be also a short Q&A, and feel free to ask questions. Just a quick recap of myself. I'm from the Civil and Environmental Engineering Department, and I also work on green building and also about BIM, building information modeling, and also smart city. In particular, in the industry, I have been involved in the Hong Kong Construction Industry Council, and also the chairperson of BIM committee, and I'm also happy to be as a director of the Hong Kong GPC, in which I try to promote the climate change action, particularly about carbon footprint. Before I start, I would like to thank my team members. They are actually doing the hard work at the back end. To start with the topic, today we have many good speakers talking about different aspects of embodied carbon. But why are we interested in that? I think many of you already know that we have a target to achieve carbon neutrality by 2050. In China, the target is 2060, so we are 10 years ahead and more aggressive. And we also target to be the peak by 2030. So if you want to know more about the target, the carbon neutrality mission in Hong Kong, you can go to this website. But in particular, we know that this kind of carbon neutrality target or initiative is not only in Hong Kong or in China. It is actually a global need, global trend. If we look at the World GBC, the World Green Building Council has the theme of advancing net zero. And they have the target that by 2030, all the new buildings must operate as net zero carbon. But when we talk about the whole life cycle, then this is also something that we need to consider. So in fact, when we talk about carbon footprint, we need to look at the whole life cycle rather than only the operational carbon. What is embodied carbon? What is operational carbon? As the first speaker today, I would like to mention that for the whole life cycle, from design to construction to facility management, embodied carbon is the carbon footprint arising during the material use, the raw material production and transportation, while the operational carbon is about the carbon footprint during the operation of the building. But in fact, if we look at another definition about the whole life cycle, we can see that we have the A1, A, B, C. The A mainly will be about the design and also about the upfront. Okay, so this is what we call the upfront embodied carbon, including the raw material, production, transportation, and even the site work. And the B is the operation. And we also have C, which is about the end of life, the deconstruction, the disposal, etc. Those will also be the embodied carbon, but this is not our target. Our target mainly is about the upfront one, okay? And that's why today I would like to share with you about the options to reduce the embodied carbon, mainly in this scope, A1 to A5. Why are we interested in embodied carbon? If we look at the whole life cycle of a building, we can see that the embodied carbon of during the construction, the embodied carbon would contribute about 27 or 30%. It really depends on many factors like the construction method, etc. But at the same time, now many people try to focus on the operational carbon, how to do green, etc. But in fact, if we consider some buildings, let's say maybe in mainland China, maybe the lifespan of a building is only like 30%, etc. Then in that case, the embodied carbon will be very important, almost like half. Even though for a typical building like 50 years, 30% of the life cycle carbon footprint is still very important, and we shouldn't ignore this one. So the question is, how can we reduce the embodied carbon of a building or building infrastructure in general, even like bridges or roads, etc. What can we do? Okay, so in following, I would like to share with you some options to reduce the embodied carbon in 3 main areas. One is the building materials, and then the building design, and also about the construction part. So first of all, I would share with you about the building material. For building material, I know that later there will be also other speakers talking about that. For our construction of buildings, the main building materials will be concrete and steel. For concrete, there are many methods that we can do for reducing the embodied carbon. Particularly, for example, we can design the fill mix, design the concrete mix, so that we can consider the workability, the strength, etc. We also can add the cementitious substitution material, and particularly the fly ash or the GGBS or silica film. Each of them has different limitation, and also, for example, the supply shortage or supply constraint and consideration. But also they have the corresponding limit on the maximum use of that. For example, fly ash, we can use up to like 25–30% only. And GGBS, we can use more. Okay, so that's why for GGBS, if we go to push the limit and then use the maximum, using GGBS can achieve a lower carbon concrete. Okay, but of course, we need to consider the material property, etc. There are other technologies, for example, the CCUS, the utilization storage, and also the carbon curing technology can also help us to provide better concrete. Another thing for steel, we usually will compare the EAF and BF-BOF, particularly if we use the EAF, the electric arc furnace, the embodied carbon will be smaller, okay? And also, one way to reduce the embodied carbon of steel is the recycling content, okay? And this depends on our procurement. Another option is using timber. In Hong Kong, concrete and steel are the major building materials, but there's uprising trend that we can use timber and combine with steel to have a composite building component, so that we can use it for partition walls, etc. And this is something that we can consider because timber has zero carbon footprint because it comes from nature, and this can help us to reduce the carbon footprint of the entire building as a whole. All these are different technologies on a single material, but for Hong Kong, we don't have too many options or too many methods to reduce the material itself, because we don't have factory, we don't have manufacturing. So for concrete, for cement, then there's one cement supply in Hong Kong, but for steel or other materials usually will be imported. So the problem is that how can we consider this in procurement? So the green procurement is more important. We need to know what are good, what are not good, so that we can select the materials accordingly and also consider the sources. Give you one example. We have worked with Swire to calculate the embodied carbon of one commercial building called One Taikoo Place. In this building, this is a green building with a lot of platinum certification. We try to calculate, and this is a RC structure with a core frame structure, okay? And when we calculate the embodied carbon, we find out that the material contribute 96%, and among which the transportation contribute about 5-6% of the embodied carbon, and about the materials, concrete contribute 30%. Rebar contribute 52%, 53%. So all the steel altogether contribute about 56%. And then glass and timber will be the remaining. And we can see that that's why if we can reduce the carbon footprint of concrete and rebar, then we can really reduce the embodied carbon of the building. Okay. And these are just some more information about the emission factors that we use, and we actually consider the local embodied carbon emission factor. Okay, and this one shows that if we consider recycling of steel, and if we consider the fly ash GGBS, then we can have some reduction in the embodied carbon. For example, the current design, the number is 575 CO2 equivalent per meter per square meter. If we use 35% fly ash, then we have 11% reduction. If we use GGBS to the maximum, 75%, then we can achieve 21% reduction. Okay, and for recycling, if we use 30% recycling, then we can reduce 4%. But if we go to 100% recycling of steel using EAF, then we can achieve 34%. If we do both, then basically it's the sum of these two numbers. So this shows that if we try to select or try to use low carbon material with the same design, then we can achieve almost like 50% of the reduction for embodied carbon of a typical building. And this is something for us to think about. Besides materials, in fact, we can also reduce the embodied carbon by the design, better design. And this one shows a list of some items. For example, when we do the low carbon building design, we can consider the geometry, we can consider different orientation, we can do the location, etc. And then all these can affect the selection of the materials, and for example, the foundation, design, etc. And also, we can do some design optimization. And with that, digitization can help. And later, I will show you some example. We can also consider the embodied type of MEP materials, and then we can reduce the use of the metal, etc. There's other consideration like DFMA. If we can design for manufacturing and assembly, we can reduce the waste. And then we can, in this case, for example, concrete, we can reduce the material waste, which will also reduce the embodied carbon of the construction. And then we can also design for deconstruction, and also we can select low carbon material. Particularly, I want to share with you how digitalization can help us to have better design. I think many of you may have heard of the building information modeling, BIM. With a single building, then we can support different analysis. For example, structural design and ventilation design, etc., material design with that. And we have studied this one using a single BIM model, and we consider the embodied carbon and also the operational carbon then we can have the total life cycle carbon optimization. For embodied carbon, the approach is that because with BIM is object-based, and then we can know what is the amount of different materials, for example, concrete, etc. And with that, then we can do the quantity curve and then consider the emission factor, then we can know the embodied carbon. And with that one, then we can consider this as the objective function and do some generative design. And we can generate different or many different alternatives using parametric modeling. And with that, then we can do something like that. For example, we can have different permutation and then ask the computer to tell me what will be the embodied carbon for that design. And we try to select the best one with the compliance of the code and also the requirement of the payload, etc. With B model, then we can also consider different materials. For example, we can select, maybe the different low carbon concrete, okay, with different materials. In fact, for example, for concrete, we have C30, we have C60. C60 have double strength as C30, right? But in fact, the carbon footprint is not double. Okay, so meaning that if we use high strength concrete, even though we double the strength of the concrete, but the carbon footprint actually is less than double. Okay, and it means that if we have this consideration with this model, then I can consider that if I use high strength, maybe high strength concrete, and then I can reduce the member size, what will be the changes in the embodied carbon? And digitalization or this digital model can allow us to do this kind of assessment. Another thing is when we do the design, then we can consider, for example, what are the partitions so that I can still have the same structural strength and performance for the building, but I can use fewer materials, fewer partition, etc. And with a better design, then I can reduce the use of the material, in a sense, reduce the embodied carbon. We talk about modular design. So our team also try to consider the selection of the module, the orientation of the module, so that we can have, say, better ventilation and also fewer material use, and digitalization can allow us. So this one shows one example that with B model, then we can show, in the preliminary design, we already can consider many different kinds of geometry, and then we can see what will be the carbon footprint of the building. And with this kind of idea, we can quickly consider many options, okay? Quickly consider many options, and it can help us to have better design, okay? Yeah. So I think so something like that. And then we can consider maybe a different building shape, building size will affect the embodied carbon. And the last part is about construction. For construction, basically, we are talking about A4 and A5. For A4, it's about transportation to the site. For this, then we can consider what will be the logistic planning. We can select a better route so that we don't need to travel a long time. We also need to select the transportation mode so that maybe cars are not as good as or land transport may not be as good as ship transport, something like that. We can also select the transport means, for example, electric, the truck, etc. Also the selection of the fuel, for example, some biofuel. For site operation, we can also use biofuel, and also we can consider the construction method or some kind of waste management, etc. And as a summary, we can see that we can try to reduce the embodied carbon by different means in these three main aspects. But in fact, the World Green Building Council have mentioned this chart saying that, of course, we can try to build efficiently, we can build smart, but we in the planning stage can even consider whether we can build less or even build nothing. Build nothing doesn't mean that we just don't build anything, but means that are the building really needed, or is there any situation that maybe they can integrate, or we can use existing assets to do so, and to still fulfill the the city need, the demand. So this is something that we may consider. And another thought is that we may also need to have some kind of measurement of the embodied carbon. While we try to have different technique or the approaches to reduce the embodied carbon, but in fact, how good are we? Okay, we need to first of all have a baseline. We need to first of all know what is the values or the emission factor for different materials. But the tricky part of embodied carbon is that it's region specific. The same material produced in Hong Kong will have different embodied carbon as the same material produced in, let's say, Japan. Okay, because we have different fuel mix. And also we need to consider the transportation. So that's why there's a need for establishing a local embodied carbon inventory database. And right now in Hong Kong, we don't have such a database, but we can see that in Switzerland, in Europe and Korea, they have such a database, but most of them do not focus on consumer materials. So that's why we, Hong Kong University, tried to establish a database, but it actually required the collaboration in the whole industry to do that. And now in Hong Kong GBC, we are also discussing something like that. So hopefully we can really have a local database so that we can let the whole industry use it and then as a baseline, okay, as a reference. Another thing to consider is we now measure, but how good are they, or what would be the target to do the reduction? So there are different kind of baseline or even targets for embodied carbon in different regions or countries. Take London as one example. London have the LETI, they have the the baseline, and also they have the target about what would be the embodied carbon of the buildings. And in Hong Kong, in fact, we also internally considering what will be the baseline and also what will be the target. Okay, for example, we hope to have a target by 2030, 2040, and 2050. And by 2050, hopefully we can achieve zero. Okay, and these are the numbers that we still need to consider with reference to many buildings. So all these are what I would like to talk about or share with you about the options of reducing embodied carbon for Hong Kong. And there are many things we still need to do, and hopefully we can work together to achieve that. So this is what I would like to share today. Thank you very much. May I pass the time to Felix or to the MC?
Yeah, thank you, Professor. We are now going to begin answering the question submitted in the Q&A box during the presentation. If you have, please feel free to drop. Before that, I have some question for you. Professor, you have mentioned the carbon capture and storage, the CCUS. What do you think about the potential? Yeah, because currently, as far as I know, CCUS is quite not popular at all, but everyone talk about it. What do you think is about the potential for CCUS? Yeah,
I think the technology is feasible and it has been proven, but there may be consideration about the cost. Okay, and I earlier I've been to one project and they use CCUS for the bricks, and then from mainland China, and then ship the brick to here. So and then the concrete bricks. Okay, so I think that is feasible, but I probably need to want to know the technical challenge in terms of the construction. So that means when we really use the material using CCUS, what will be the difference in terms of the material property? Yeah, because frankly speaking, I'm not too sure about the hidden limitation of that. But I actually have looked at the concrete using, like say the fly ash or GGBS. They have longer setting time. And meaning that if they use this kind of cementitious substitution materials, the construction time may be longer.
Okay.
And that will be a consideration for contractor. So for CCUS, then I don't know about the construction process. I actually have talked to those suppliers. They said that it will be the same. Okay. But I probably need to look at more figures to have a conclusive statement.
Thank you. And you have called a case on Swire property, which is a very successful that dry down the embodied carbon. Do they share with you about the cost price difference? Yeah, I suppose there's decision. The drawback is good, that is that they reduce a lot of carbon, but there might be drawback is the construction cost will be higher. I don't know whether they have shared some of these kind of drawback to you.
Yeah, I totally agree. In fact, I also have talked to the other project. They try to use, say, 100% recycling for the steel, or they add the fly ash for the concrete. They can reduce the embodied carbon, but the cost actually will increase. For example, GGBS. GGBS is not that rich in supply. So that's why there will be increasing cost, no doubt. And but somehow, also for 100% recycled steel is also in shortage. I heard that. So that is something that one thing I hope the industry can help is try to find those sourcing. Okay. And also, I think the client hopefully can understand this one and then have a higher premium for this kind of low carbon building. And so that they can encourage. If the client can put this one in the spec, then that will be better. And it is actually something related to their CSR. If they can link up with the CSR and think that this is doing something good and then relate to carbon neutrality, I think they will know that there's some premium they need to pay.
Yeah. Thank you, Professor. In fact, it's a good news that I know that you are working on a platform for producing the embodied carbon for construction material. Yeah. In case you have any update, or maybe I think a lot of the audience from our side are very interested to know it. Yeah, because as you mentioned, without data, somehow it's very difficult to help people to make a right decision in making procurement.
Yeah.
Yeah.
Right.
Thank you very much. Yeah.
Yes. Thank you.